It is now that we must answer another question that might be popping up in your head. Where is a Scala used in software development lifecycle? Is it even relevant for my work? Based on your education and experience, you may be any or all of the following. A front-end engineer who fiddles to make web pages look consistent across all devices. Or a back-end engineer who scratches their head figuring out the race conditions in their bug. Or a distributed systems engineer finding traces of an event that disappeared without logging anything. Or a big data engineer who always pushes to make standard data pipelines yet always finds an exception no matter what. Or a machine learning engineer who always finds invalid training data causing their models to overfit or creating biases. And you might be wondering, is a Scala valuable for me? Can I use a Scala in my work? Is it even relevant for me? I have a good news for you. Scala exists at all levels of software lifecycle. It may not be a popular choice at one level comparing to the other one, but surely it is there and you can start learning it today, period. But before you jump in, let me share more information so you get sense of it. Let's look at a few application architectures to see how Scala fits well in those scenarios. In a standard 3-tier web application, we need 3 components. We need a front-end to input the data, a backend server to validate and process the inputs, and finally a database to save the data so that it can be accessed later by the user. We also need an API layer so that the application can send or receive the data. In such a scenario, you would typically write JavaScript for the front end. However, we know that JavaScript is an interpreted language and you cannot get the compile time safety there. There are a lot of options available in this space if you care about type safety, such as TypeScript or Dart. But hey, I said Scala exists everywhere, so we could use a Scala.js to build our front-end application. Scala.js is a library that you could use to build front-end applications. You can write Scala and the compiler generates the JavaScript for you. You could also import the popular JavaScript libraries like React as part of your project. So this part of the application is handled here. Now for writing backend server, there are many choices, but the 2 most popular ones are Play Framework and Akka. Play Framework is a full-blown model view controller framework that provides all the features you need to build a server, create APIs, and generating HTML templates and working with the databases. Akka, on the other hand, is a toolkit, not a framework, where you could pick the tool you need for the job. Akka is a very popular toolkit in Scala community. For our use case, you could use Akka HTTP module and build HTTP server with very minimal code. In fact, the Play framework relies on Akka to provide many of its features in its framework. To interact with the database, assuming it is a relational DB, you could leverage Slick. Slick is a library that could be used to interact with databases in a type-safe manner. It supports almost all popular relational data stores such as MySQL, Postgres, and Oracle, and also provides an in-memory database support with H2 database. With Slick, you interact with the database as you would interact with any other Scala collection. This makes your programming much more easy and fun to work with. So now that we have covered our first architecture in Scala, let's look at the another one. In this scenario, you may be writing a purely front-end web application with application logic written in JavaScript. Here, once your application is ready, you would keep them on a static file storage such as Amazon S3, Surge, or Firebase hosting. As we have seen in the previous architecture diagram, you could use Scala.js to write the Scala code and generate the JavaScript artifact and deploy them to the service you like. By writing JavaScript in Scala, you are safe that no runtime bugs will blow up your application in production. In this third scenario, you would typically have many devices or sensors which are emitting events to your server using an API. On your server, you would collect these events, process them using an extract transform load pipeline, and push the result into the database. For such an application, we could decouple the event arrival from its processing by using a publisher-subscriber model. We could leverage projects such as Kafka, which is also written in Scala and Java, to queue the events as they arrive and not blocking the publisher. Then there could be a number of workers who would pull these events and process them and persist them into the data store. For such a processing and job coordination, we could leverage Akka toolkit. We could use tools such as Akka cluster, streams, distributed data, and actors to build such a system. On the other side, you might have a use case where you have loads of data and you want to build a machine learning model for a business problem. You may want to load them up using an API, which would further process the data, train the model, and persist the coefficients back into the database. Your users could then interact with your models using these coefficients. For such scenarios, you may want to leverage Akka toolkit and libraries such as Apache Spark, Breeze, Epic, Flink, and Prediction IO to train and develop your models. As you see, Scala is for everyone and is everywhere. No matter what experience you have or no experience at all, you can start today, learn the language, and build awesome products. Best of all, learning one language enables you to work on any other part of the architecture.